Paul Randall with SQLskills.com. What I'm going to do today for you is a screencast to support the effective database maintenance article that I wrote for the August 2008 issue of TechNet magazine. A couple of the concepts that I talk about in that article are the need to monitor fragmentation in indexes. And so the script that I'm going to show you uses the DMV that I mentioned, sys.dmdb index physical stats. And what I'm going to do is I'm also going to illustrate the fact that you shouldn't run shrink. One of the other things that I talk about in the article is how you shouldn't have auto shrink turned on. And so I'm going to show you the effect of shrink on a newly created clustered index and just show you how bad it really is. So what I have here, and I'll post this script to my blog once the article comes out. What I have here is I'm going to create a small database called shrink test, and then I'm going to create a clustered index inside it and show you the effect of having shrink run on it. So I've created my database called shrink test, and now I'm going to create a filler table. What I'm going to do is I'm going to create about 10 megabytes of space taken up at the start of the data file of this shrink test database. Then I'm going to create my production table, which will be further on in the file, and then later I will drop my filler table, thus creating some free space, and then I'm going to simulate an auto shrink by running a manual shrink command, and we'll see the effect on the fragmentation of the clustered index. So I'm going to go ahead and create my filler table. It's just got 10 megabytes of junk in it. So that gets created. And then directly after that in the file, I'm going to create the kind of production table. So again, it's nothing interesting in the production table, it's just to illustrate the points. So there's a table and a clustered index on it. And then I'm going to fill that up with some data as well. So again, about 10 megabytes of data in there. So now I'm going to use the DMV that I mentioned, and the DMV is in 2005. It's a replacement for the dbcc showconfig command that I mentioned from SQL Server 2000. Now the way that you can run this command is there's three different modes, and I've highlighted there the mode at the bottom, which is limited. You can use limited, sampled, or detailed. Detailed will give you absolutely everything there is to know about that particular index. Limited will do a smaller scan from using parts of the upper levels of the index to just get the fragmentation information. And a sampled scan will kind of do a detailed scan, but if you've got a very, very large table, it'll do a 1% sample of the index rather than having to scan all the pages. So I'm asking for a limited scan because I just want to look at the fragmentation. The other parameters there are the database ID, the object ID of my table, the index ID, which of course is 1 because it's a clustered index, and then the partition ID. Now I haven't specified any partitioning for this, so I've put in a null, which means all the partitions. So I'm selecting the average fragmentation in %, which is just my fragmentation, and the fragment count. I want to see how many fragments the index is broken up into. So I'm going to go ahead and run that query. And you can see there that the fragment count is 6, it's very low, and the average fragmentation in % is 0.4%. It's a brand new index, it's only just been created, and so there's very, very little fragmentation, which is what I'd expect. So now I'm going to go ahead and drop the filler table. So I'm going to create about 10 megabytes of free space at the start of that database file. And now I'm going to simulate an auto shrink running. Now I would have to wait half an hour for auto shrink to kick in if I actually had auto shrink turned on in this database. So I'm going to simulate it by manually running a dbcc shrink database command, which does exactly the same as an auto shrink. So we run our shrink, and then I'm going to go back and I'm going to see the effect on the fragmentation of the clustered index. I'm going to run exactly the same query that I ran before using the same DMV. And remember, we had 0.4% fragmentation before, and now we have 99.8% fragmentation. And what shrink has done is, the way that shrink works is it goes to the end of the allocated space in the file, it picks up a single page, and it moves it as far towards the front of the file as it can. And then it goes back to the new end of the file, picks up the next page, and moves it as far forward as it can. So what in effect it's done to our brand new index is it's reversed the order of the pages. So it's actually caused perfect fragmentation. Now, an auto shrink is obviously not going to cause perfect fragmentation because it's not going to have a whole bunch of new indexes most times it's run. But you can see for indexes that are in flight, lots of inserts, updates, and deletes happening on them, if you were to run an auto shrink, it would cause massive amounts of fragmentation in the index. So just a short demo there to show you using the DMV that I mentioned in the article and illustrating for you the point that I make in the article about how shrink can cause fragmentation, and so you shouldn't have auto shrink turned on. Hope this is useful to you. Thank you.